Hello everyone, welcome to day 12 of Leetcode May challenge. Today we have question number 41, permutation 2. So in this question they have given us a collection of numbers, nums, that might contain duplicates, written all the possible unique permutation in any order. So let's understand it. So permutation, we have to take out the permutations, but there should be no duplicates. So if we have the integer array of distinct integer, then taking out the permutation is easy. How we take out the permutation is, so basically in normal terms if I'll tell you, we have these three places and we have to find how many total permutation will be there. So total number of ways we can fill this place is 3, because we have 3, like the length of our array is 3, 2, 3, 4, so any number can come here. Then over here 1 is already filled, so we are left out with 2 integers, so any 2 can come here. When both of these places are filled, we are left out with 1, so 1 will come here. So total ways is 3 factorial. Same in this case, we have 6, like total ways is 3 factorial, that is 6. So let's see how we'll do this. So if we have the integer array of 2, 3, 4 and if we have to find the permutation, our first thing will be, we will add 2 and we are left out with 3 and 4. We will add 3 and we are left out with 2 and 4. We will add 4 and we are left out with 2 and 3. On the next level, we are going with 2 and 3. Then we are left out with 4. If we are going with 2 and 4, then we are left out with 3. If we are going with 3 and 2, then we are left out with 4. If this is, let's write it over here. If we are going with 3 and 4, then we are left out with 2 over here. If we are going with 4 and 2, then we are left out with 3. If we are going with 4 and 3, we are left out with 2. So on the next level, we will get the combination, like permutation of 2, 3 and 4 from this branch. From this branch we will get the permutation 2, 4 and 3. From this branch we will get 3, 2 and 4. From this branch we will get 3, 4 and 2. From this branch we will get 4, 2 and 3. And from this branch we will get 4, 3 and 2. Let me change pen color to red. Yeah. So our final permutation which will form from these three numbers are, this is 1, 2, 3, 4. 2, 4, 3 is our second. 3, 2, 4 is our third. 3, 4, 2 is our fourth permutation. This is 4, 2, 3 is our fifth. And 4, 3, 2 is our sixth. So n numbers, so n factorial is the permutation we'll get. So in this case it was 6. 3 factorial, that is 6. So this is the answer. But this is the answer when we have no duplicate case. Like all we have 2, 3, 4, these all are distinct integer. What if we have example somewhat like 1, 1, 1, 1, 2, 3, and then if we need to calculate the permutation, what we will do? So if we have the number like 1, 1, 2 and 3, and then if we need to take out the combination, then what mistake we will do is, like from 1, 1, 2, 3, we will have one way is like we are going with 1 and we have option of 1, 2, 3, and then we are taking 1 and then we have option 2 and 3, and then we are going with 2, then we have option 3, and then lastly the only option we can use is 3. This is for if suppose this is 0, like 1 presented index 0, that this is branch for that, and suppose this is 1 presented index 1. If we are making for that, it will also somewhat will look like this. This is 1 and then we are left with 1 present at the index 0, 2 and 3. This I am talking only about the permutation starting with this 1. Though they'll start from 2 and 3 also, but here I am showing you the duplicate case. So again we will use 1, we are left with 2 and 3. If we use 2, we are left with 3. And if we again use 3, we are left with nothing. So in this case our answer is 1, 1, 2 and 3. If we are going with 1 at index 0, and if we are going with 1 at index 1, then our combination is 1, 1, 2, 3. These both are same combination, so basically they are duplicates. So in this question we have to make sure that while we are creating the permutation, there should be no duplicates. So how can we do this? To do this is, one option is using hash map. We already know that hash map is famous for, like, it only take the unique element, it does not contain duplicates. So we can create a frequency map and can fill the values in it, and from that we can create our permutations. So here we will create a hash map. We will have where we will have the key and the value or the count. So 1 we can see in this array appear 2 times, so 1 frequency will be 2. This is basically a frequency map which we are making. And then 2 is present in our integer array 1 time only, and then 3 is present 1 time. So this is a frequency map, and now using this frequency map we will find the permutation. So now the distinct element we will see from the hash map, that is 1, 2 and 3, and now we will take out its permutation. So if we are using 1, our this count will decrease and we are left, its count becomes 1, and then if we are using 2, then its count will become 0, and then when we are using 3, then here we got like 1 permutation is 1, 1, 2, 3, so this count is also become 0. And now when we'll backtrack, we can go with 2 also. Of course when we are backtracking, its count will again increase by 1, and this will also be 1. So when we'll backtrack, now we are going with 2, so now its count will become 0. And with 2 we have options like either we can go with 1 or we can go with 3. If we are going with 1, then we are using here 3 over here because that is the only element left in the array. If we are going with 3, we'll write here 1 because that is the only element left in the array. Then again we'll backtrack and then we'll go over here, and then from 1 we can use like 3, and from 3 we again have 2 options. Either we can go with 2 and 1, or we can go with 1 and 2. So the different permutation which we got is like 1, 1, 2, 3, 1, 2, 1, 3, 1, 2, 3, 1, 1, 3, 2, 1, and 1, 3, 1, 2. Similarly for 2 and 3 we will do. So this is how we are going. We will make sure that there is no duplicacy allowed, because 1 we are taking only 1 time, and then we are finding it's all the permutation. There is no other one, and then we will similarly do for 2. like we will go for from 1, we will go for 3, and then we will found the permutation space. Then similarly we'll go for 3, where we'll have the branches with 2 and 1, and then we'll found the permutation. So there is no other one coming, so there is no duplicacy. So this is how, using the hash map, we can remove the duplicacy and find the permutation. So let's see the code. First thing is list of list. We will make the result, that is new array list, and the other thing is we have to create a frequency map, so that will be of integer, and integer is to new hash map, and then we will make a variable which will have nums dot length, and then we will make a frequency map. So that is the ordinary method we are going to follow, very famous method to count frequency, that is element in the array nums. In map we will put element dot map dot get or default element comma 0 plus 1. If the element already present in the 1, then just add 1 to its frequency. If it's not there, then give 0. Like default value is 0 and we just have to add 1. Okay, and then what we will do, at last we have to return this result list of list, but before that we have to find the permutation. So for that we will go on the method called dfs function, that will give us the permutation. For that we'll pass the nums dot length, and we will pass result, we will pass an new array list, and what we will pass map. Now we will write the dfs function, void, we will have integer n, then we will have list of result, then we will have array list, so list of type integer list, and last we will have the map. What we have to do is, first thing is, if list dot size is equal to n, then we will simply add that list in our result list, otherwise we have to fill it. So for that what we will do, we will loop the hash map, because we don't need the duplicates. Set, and then we will find the key that we will get from set dot get key, and integer count or value we will say, let's say it count is equals to set dot get value. So we will check if our count is greater than 0, then first thing we will do is we will add that key in our list, and we will map dot put get comma map dot get key, and we will reduce its count -1, and then we will again call a dfs function. We'll pass n, we'll pass result, we'll pass our list, and we'll pass map, and while coming back we'll backtrack, that is list dot remove the last element, that is list dot size -1, and we will increase it count also, that we have decreased. So key map dot get key +1. Let's run this. It's running. Let's submit it. So now the thing is frequency. So as we know that we have n element, and for every n element we are going n factorial deep. Okay, so for every n element we are going n factorial deep. So this is our time complexity. And yeah, of course, when if we have like duplicates, then we are having n numbers, but we are only traveling for n minus 1, and we are going n numbers deep, so that is n factorial. So this is big O of n minus 1 into n factorial. Okay, so this is for the duplicates in this case. Okay, yeah, we are done. Thank you.